So in this video, I'm going to make a new blower for my furnace. So here's a look at the old blower. Essentially we had a blower, which in my case was either a vacuum cleaner turned backwards or a leaf blower. That goes into some pipe, and here we have a tank of oil. We have an oil line going in the pipe, and it goes through, and then by the Venturi effect, as the air goes past this, this way. Sorry, I'm trying to do both at the same time. Anyway, it's going to pull oil from this center tube, and it's going to go out. So the issue I have with this is that, one, it's very difficult to start. I can't light this oil immediately. I need to build a fire in the furnace, let it burn, hope it keeps going, it doesn't burn out, and keep it going for a while to get it up to temp. Slowly turn this on until it catches. I could use propane to get it up to temp, and then turn the oil on, but I don't want it. That doesn't seem like an elegant solution. So the issue with this is it sometimes takes me a really long time to start this thing up. It might take an hour because the fire keeps going out, or I start the oil too soon and it puts the fire out and it's not hot enough yet. And I'm just thinking, man, if I want to finish my steam engine in this century, then I need to have a better design. So here's the better design. So here's the design I'm going to use, and one thing I forgot to mention is that in my old design, it's pretty fuel inefficient. I burn about 4 gallons an hour, which is a lot. So this design I got from, I don't remember the YouTube channel name, I'll put it in text down below, but his videos help me kind of figure out what I need to do here. So it's kind of hard to see, but we have one pipe going, this is just a straight pipe with a T in it, and then inside that pipe we have another pipe going through, and you can kind of see that. Sorry about my drawing. So from here to here is one pipe, and then from here to here is another pipe. So this pipe's in that pipe, and this pipe carries oil and this pipe carries air, and at the end here we have a very, very small gap, just barely anything. And what will happen is the air will kind of come out like this and create a negative pressure area here, and that will draw the air out, and then the oil out, and that will combine with this rushing air, and it should make a really, really fine oil mist. And the benefit of this is, one, it should be more fuel efficient. Two, I should be able to light it immediately, both of those things will help tremendously in actually finishing my steam engine and making castings in a reasonable amount of time. Because right now it takes me, it's on the order of four hours for one casting, and it's an ordeal. So I want to get away from that. So let's get started. Okay, so just figuring this out as I go. Let's put you guys forward a little bit. This is what I'm thinking. I got a T, and air goes here. You have this. Okay, there's that. Okay, so this is what I'm thinking. We gotta, man, it's not long enough. I can weld one on. That might work. So I'm thinking, punch a hole in this. This is the back. Run this guy through here, and obviously it needs to be longer. These are the longest ones they've had. So punch a hole through this, pass this through, it's gotta be longer, and punch a hole through this that's just barely bigger than this diameter, right? And then just make it just barely bigger than this, so there's just a little orifice. But then this is the oil line, right? But then this is too much, that's too big. So I think I'm gonna weld this closed and then drill a little tiny hole in it. I'm not sure if that will work, but I'm kind of experimenting here, so let's try it. Okay, so because the pipe is so long, the back cap, what I'm gonna do now, it needs to be in here really straight so that the hole is really perpendicular. So I think I'm going to do something like that, but hold on. Okay, so we're going to put a piece of flat bar and then push that against it and then tighten it up. Or really tighten the piss out of it. Okay. So that looks pretty. There might be a little bit of run out in that, but it's hard because this is like, I don't think they're castings anymore. This is like a forged steel thing, I think. I don't know how they make black pipe. It kind of has that casting look, but I doubt they're doing that. If anybody knows, let me know. So we're gonna. Let me get a center drill. Okay, I'm gonna tighten that up. We're just gonna put just a little dimple. Can't see in there. There we go. That's pretty good. Might be a little big, but I'm going to weld it in place, and this actually is good because it gives me room to kind of align it perfectly and then tack it in place. So, cool. Let's take that out. Okay, so I went ahead and did the other cap off camera, but now I'm gonna try to weld these two pipes together so that I have a longer pipe. I got them as straight as I can get them. I hope it's gonna be all right. We're gonna see, and I'm choosing to use the oxyacetylene because I really enjoy oxyacetylene. I'm trying to get better at it. So why not? Okay, that looks pretty good. Okay, so there's the welds ground down so that it fits through this. Come on. Ow, that hurt. Okay, so now what's good about this, so I'm going to weld this in place when it's flush. By weld it in place, I mean down here on the cap. And then that means turning the cap, I'd be able to adjust it. I'll put it flush. It's only going to tighten from here. And if it's too far, well, let me put it a little bit before flush. Because like I said, things are just going to tighten. And I hope this is going to be alright. Okay, so I have it in the vise. And it's clamped the right spot. So if the vise doesn't suck tons of heat out of that. Let me use the torch again. Okay, so while that's cooling, I need kind of like a reservoir just to test things out. So I just have this big piece of pipe. I'm just gonna put a cap on the bottom, fill that up. Then I'm going to drill a hole and then weld this little pipe in there, and then I'll have a tube. Damn, man, I'm really having a hard time. Then I'll have a tube that goes from this pipe to this pipe that will carry the liquid, which in the first test is going to be water, but ultimately it's going to be oil. So off camera, I'm going to drill the hole in this cap in the same way I drilled the other hole. Just put it in the lathe chuck, square it up, and then just drill that way. I'm going to do that off camera because it's kind of boring. So I'll be back. I finished the reservoir. I'll show you that in a second. And I did a little test to see if this works, and I hope this is in camera. And so I have a little valve on this reservoir. I'm going to hook up air. And we're going to open the valve. And then we're going to... That's a little droplet-y. So I'm going to increase the pressure. Let's get a little stream going. There we go. Okay, oops. So that worked pretty well. It drains this reservoir pretty quick. Let me give you a close-up on the reservoir. So here's the reservoir. I put the cap on it and then just welded in this little ball valve. And then there's a hose attached to this guy. And I did a little bit of adjustment until I got a good amount of suction on there. And the thread sticking out probably isn't the best, but it works okay, so I'm still experimenting. So this hole might be too big, which might explain why I'm just dumping the water out. I don't want to dump the water out. I want to kind of have a more constant stream of things. So I'm going to keep playing with this until I get it just right. I'm going to close this up and we're going to try it again. You know, that's a pretty small hole, and then I don't have to drill it. That's just for me. So let's try that. Okay, so now let's see how this works. If it works any better. Alright guys, so this is several days later. I didn't show you all this work, but pretty much the nozzle that I made is right here, and I just tacked, you know, this nozzle to this pipe here, welded this on, and this is kind of just like a, I don't know, a big jet. And this is a hole where I'm going to light it. I've already, well, okay, so, and then I have a rotor there that I welded this on. I don't remember what I showed in the last video because it's been quite a while, but here's my whole setup. So I was experimenting to get this just right, and I believe I have. So the way this is going to work, we got the fuel coming down here, goes into the nozzle, air pressure's here. We're going to turn them both on and light it. Heating up this oil helps considerably in lighting. I think that should be good. Now we're going to connect our air line. I did a little bit of math to figure out the fuel consumption. Now, I had kind of just an arbitrary intensity on that flame. What I need for the furnace might be more, might be less, I don't know. So the little canister on top, the reservoir, these are the dimensions in inches. And so I went through 5 of these in 25 minutes. I ran the thing for 25 minutes. So the volume of one of those things, pi r squared h, this is their diameter divided by 2, because it's the radius times the height. That gives me 18 3/4 cubic inches. Multiplied by 5, 91.88 cubic inches. Therefore, the rate is that total volume divided by the total time, 91.88 divided by 23 minutes, 4 cubic inches a minute. Then multiply that by 60 to get 239.7 cubic inches per hour. Convert this into gallons. It's approximately 1.03 gallons per hour. Let me just double check that because I'm going off of memory here.
239.7 cubic inches converts to about 1.04 gallons.
Okay, so that's pretty, I was close. So pretty much a gallon an hour, which is, that's about my old one. I was getting like 4 gallons an hour, so that's like 4 times better than my old design. That's a really good consumption rate. Now again, I don't know what intensity I'm going to need for the furnace. It was pretty intense the way I had it, so I think it'll be alright, but it's likely I might need a little more, but still, I think I have room to spare. Another thing that I kept an eye on and was testing is whether or not my air compressor can keep up. It started at full, which was 150 psi, and I was running the blower, that whole assembly, at around 100, and the valve wasn't open all the way. It was probably open, let's say that much. Was not open, so it wasn't the full 100 psi. But the compressor it kept going down, 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 and it kind of stabilized around 80 psi. Sorry, I'm looking over to the side. It stabilized around 80, and it seemed to stay there. I could have ran it longer, but it was getting kind of late, and I wanted to close up shop here. So it'd be nice if I had a bigger compressor, and I actually do have a bigger compressor, and I made a special room for it, so it's all insulated so you can't hear it when it runs. So this is a much bigger compressor, but it's not plumbed up. So it's much quieter. But yeah, it's not plumbed up, so I'd love to get that plumbed so I can use the big compressor, but I do think the small one would be okay. 80 psi seemed to be enough to keep it going. So I think that's going to be it for this video, guys. I will probably start a whole new build on making, this thing was just a prototype. So now that I know how it works and how to make one, I'm going to start building this to be retrofitted to fit on the furnace, and I can use it like that. So I'll bring you guys along for that build for sure. So we're getting closer to doing another pour. It's probably still a decently long time away though, but we're getting there slowly, little by little. So anyway, thanks for watching, guys. I'll see you next time.